Welcome back. Today we'll do algebraic expressions, chapter number 10. So in that, see, in algebra we represent variables as x, y and z. See, we have variables and constants. So in algebra generally we represent variables using the letters x, y and z, and the constant we represent it as a, b, p, m, etc. So now we'll start this exercise. Now the first problem in this exercise is write the following statements using variables, constants and arithmetic operations. See, variables generally we use x, y, z, constants a, b, p, m, etc. And arithmetic operation means it is a plus, minus, into, division, whatever it depends on the question. Okay. So the first problem is 6 more than p. So 6 more than p means it is 6 plus p, right? 6 more than p means it is 6 plus p. Then after that, x is reduced by 4. X is reduced by 4 means it is x minus 4. X is reduced by 4. Then after that, 8 subtracted from y. See, 8 subtracted from y. So first you have to write y. See, 8 is subtracted from y means it is y minus 8. Then q multiplied by minus 5. Q multiplied means just use the brackets or you can use into. Q multiplied by minus 5 is nothing but minus 5q. Then after that, y divided by 4. Y divided by 4. It is y by 4. Then after that, 1/4 of the product of p and q. See, 1/4, just write 1/4 of the product of p and q. 1/4 into p into q. So in algebra, into we can represent using a dot. So 1/4 into p into q. Then after that, 5 is added to 3 times of z. 5 is added to 3 times of z. So it is 5 plus 3z. 5 is added to 3 times of z. Here times means you have to multiply. 3 is to be multiplied by z. So 5 plus 3z. Then after that, the next one is x multiplied by 5 and added to 10. See, x multiplied by 5. So it is 5x. X multiplied by 5 means it is 5x and 10 is added. So just write plus 10. Then after that, 5 subtracted from 2 times of y. 5 subtracted from, 5 is subtracted from 2 times y. 5 is subtracted from 2 times y. Remember, after from whatever you have 2 times y, that you have to write first. So 5 is subtracted from 2 times y. Then after that, y multiplied by 10 and added to 13. Y multiplied by 10 added to 13. So it is 10y plus 13. This is completed. Next problem. Write the following expressions in statement. The first one is x plus 3. So how to write this x plus 3 in a statement? See, it is simple. X is added to 3. See, if x is added to 3, we will get x plus 3. And the next one is y minus 7. So y minus 7 means here 7 is subtracted. 7 is subtracted from y. 7 is subtracted from y. Right. Then after that, 10 is multiplied to L. 10L means what? 10 is multiplied to L. Then we get 10 times L, or we can write it is 10 times L. Both 10 is multiplied to L, or we can write 10 times L. Then after that, x by 5. X is divided by 5. X is divided by 5. Right. Then after that we have 3m plus L. It is 3 times m added to L. See, 3 times m added to L. 3 times m added to L. Next, after that 2y minus 5. So how to write this 2y minus 5? 2y minus 5 is nothing but 2 times y. 5 is subtracted from 2 times y. See, this is nothing but 5 is subtracted from 2 times y, or we can also write like this: 5 is subtracted from the product of 2 and y. So we can also write like this: 5 is subtracted from the product of 2 and y. Any one you can write down. Okay, so this is completed. So the next one is we have like terms and unlike terms. See, what are like terms? Like terms which contain the same variable with same exponents are called like terms. Now here 5x and 8x. See, when you consider this 5x and 8x, both are having a same variable x, right? And with the same exponent. Exponent means power of x. What is power of x here? The power of x is not given. That means the power of x is understood to be 1. So 5x and 8x are having same exponents 1, and they are of same variables xx. Only they might differ by the coefficients. No problem. So now here this 5x and 8x are called like terms. Okay, this 5x and 8x are called like terms. Now when we go to the next one, in the second case, we have a same variable a. Exponent is 2 in the 14a, in 14 in and the second term, and the first term also it is a square. So now both the exponents are same and both the variables are also same. So therefore we say 7a square and 14a square are like terms. Now next one, 3xy, 4xy. This is also a like term because the same exponents we have, same variables we have, it is a like term. Now when we come to this 3xy square and 4x square y, they are not like terms, they are unlike terms, because the reason is the power of x in the first case is 1 and in the second one it is 2. So here the power is differing, so they are not like terms, they are unlike terms. Okay, the next one is degree of monomial. See how to find the degree of a monomial. Now what is a monomial? Monomial means it consists of a single term. So now here the sum of all exponents of the variable present in a monomial is called the degree of monomial. That means we have x. So what is the power of x? It is 1. So we say the degree of monomial in the first problem is 1. And when it comes to the second problem, the degree is 2. And in the case, in the third problem, xyz is a monomial. Now how to find the degree of this 3xyz? The power of x, power of y, power of z is understood to be 1. So degree of the monomial means here you have to add all the powers of these variables, that comes to 3. Then we say the degree of the monomial 3xyz is 3. 3xyz is a monomial. Okay, binomial means what? It has 2 terms, but it is to be with between 2 terms, either you should have plus or minus, then it is binomial. Trinomial means 3 terms separated by plus or minus signs: x plus y minus z, x square plus y square plus z square. These are the examples of trinomial. These are the examples of binomial. Now when it comes to the monomial, 3xyz is a single term. These are in product, so we say it is a monomial. So the degree is 3. Now this is also monomial 8 y square z square. So the degree means add the power of y and z, 2 plus 2. So what is the degree of the monomial? It is 4. Okay, so this is about the degree of monomials. Now degree of a constant term. So constant term means without x. Suppose you take a constant called 4. Okay, so what is the degree of a constant term? The degree of a constant term is 0. How it is 0? Whenever we say constant, we don't have variable. So if I write variable, I have to write the power as 0 because x power 0, 1. 1 fours are 4. See, I am finding the degree of degree of a constant. See, now this 4 I will write it as 4x power 0. Why I am writing x power 0? Because whenever we are finding a degree of any monomial, binomial or trinomial, we need a variable. So as a constant, as a number, we don't have any variable. You write x power 0. What is x power 0? 1. Anything power 0 is 1. So 4 into 1 will become 4. Again we will get the same number. When we will get the same number if the power of x is 0? We say the degree of the monomial is always 0. Sorry, the degree of a constant is always 0. The degree of a constant is always 0. Next, the degree of algebraic expression. So whenever you get an algebraic expression 4x square plus 3xyz plus y square, in these cases we have to see the highest power and we have to write the degree. See, the highest of the degrees of all the terms of an expression is called the degree of the expression. So here, for example, the first one. So first one is clearly a monomial. So whenever you get a monomial, just add the power of x and y, we get 3. Now the second one is a binomial. Okay. Now what is the highest power? Here 3y is a monomial, x square y square is also monomial. Now the highest power is 4 because 2 plus 2, 4. As it is a monomial, if you add you will get 4. So the degree of this binomial term is 4. Now when it comes to the next one, we have x square 3xyz plus y. So the highest power we can get it here as 3. Power of x, power of y, power of z. If you add you will get 3. So the highest power is 3. So we say the degree of this expression is 3 or the degree of this trinomial is 3. Now when we will go to the fourth one, in fourth one just see the powers. 2 plus 2 4, 2 plus 1 3, 1 plus 1 2. So the highest power is clearly 4. So the degree of this expression is 4. Okay, so this is completed. Next problem. Identify and write the like terms in each of the following groups. Now here like terms means it has the same variable and same exponent. Say suppose you take a square and exponent is 2. So we have to search for another term which has a square, right? So a square and minus 2a square are like terms and the remaining are unlike. Okay, so a square comma minus 2a square are like terms in the first one. Now in the second case, what are the like terms in the second case? See, 3a we have 4xy minus yz and minus 2yz. So here yz are like terms. So the answer is minus yz and 2yz are like terms. Then the next one we'll see. Now here we have minus 2xy square. Is there any other xy square terms? Yes, we have xy square. These two are like terms. See, this is x square y, this is xy square. The degree changes here. So degree is power 2 is for x, but here power 2 is for y. It is differing. So this will become unlike term when you compare with this. So what are the like terms? It is minus 2xy square and 5 minus 2xy square and 5xy square are the like terms. Then next here we have 7p and we have minus 2p minus 3p. These three are like terms in this. So 7p minus 2p and 3p are like terms, and one more like term also is there, 8p and minus 5p. Sorry, 8pq and minus 5pq are also like terms. Okay, so this is completed. Yeah, next problem. What is the degree of each of the monomials? Now here we have 7y. So what is the power of y? Here the power is not mentioned, so it is assumed to be 1. So the degree of this monomial is 1. Next we have minus xy square. The degree of minus xy square is power of x and y you add. So the degree is 3. The next one, x y square z square is a monomial. The power of x is 1. So if we add 1 plus 2 plus 2, we will get 5. So the degree is 5. Then 11 y square z square. So power of y and z together we can add in case of monomial. So the degree of 11 y square z square is 4. Then 3mn, power of m1 n1. So 1 plus 1 is 2 and minus 5p q square. So the degree is 1 plus 2, it is 3. Okay, so this is completed.